In this video, we will revisit some basic differentiation formula from the O-level math syllabus and look at more differentiation formula that are introduced in the A-level syllabus. In this table here, we have the differentiation formula that we have learned in the O-levels. These are all going to be assumed knowledge in the A-levels. Other than the product and quotient rules, there is another important rule that we have to know in the A-level syllabus. That is the chain rule. The chain rule is very important, and thus I'll be spending a little bit more time recapping it. Now, recall that in the O-levels, when we are asked to differentiate, say, an expression of d over dx, 2x plus 1 to the power of 5, what we were taught is to simply bring the 5 down, multiply it by 2x plus 1, the original expression in a bracket, power minus 1, then multiply by 2, which is the differentiation of the term within the bracket. But what you might not know is that this is actually an application of the chain rule. How the above term was differentiated was, first, we let v equals to 2x plus 1. Therefore, differentiation of 2x plus 1 power 5 is the same as d over dx v to the power of 5. Now, the variable is now v, but we have to differentiate with respect to x, which is not possible. Therefore, we can apply the chain rule to say that this is effectively the same as d over dv v power 5 multiplied by dv over dx, such that the dv's can sort of cancel each other out, and dx comes back here, which therefore this term is essentially the same as this term. So this is the chain rule. And based on the chain rule, we know that dy over dx can be written as dy over dv times dv over dx. Or in a more general form, if we have differentiation of g of a function of fx, we can say that it is equal to g prime of fx times f prime x. We can extend this concept to the other functions that we have learned in this table over here. And based on this chain rule, we will get the following expressions. How we can get this expression is very simple. Number one, we treat fx as though it were just an x and differentiate it as per normal. So by right, we should be getting n fx n minus 1. But because of the dv dx at the back, we need to multiply an f prime x at the back. So basically, just differentiate it as per normal, replace x with fx, and finally multiply by f prime x at the back. The table given now are more differentiation formula that you are required to know in the A-level syllabus. However, very luckily, these formula are all included in the formula list given during your exams, so you do not have to memorize them, but of course it will be good to do so. Correspondingly, we can derive the formula if x were to be replaced with fx by using chain rule. In example 1, the term that we are asked to differentiate is a product of two terms, ex and cos inverse x squared. So we know we need to do product rule. Next, to differentiate cos inverse, we know we need to use the formula d over dx of cos inverse x equals to negative 1 over square root 1 minus x squared. Furthermore, instead of just an x in the cos inverse, we have x squared. So we need to do d over dx of cos inverse fx equals to negative 1 over square root 1 minus fx squared times f prime x, where fx is x squared and therefore f prime x is 2x. So with this, let's proceed to differentiating the entire term. So we have dy over dx equals to, and we do product rule, I'm going to keep ex first, and differentiate cos inverse x squared, which gives me negative 1 over square root 1 minus x squared square multiplied by 2x plus, now if I differentiate ex, I still end up with ex, and I keep cos inverse x squared, so cos inverse x squared. And if I simplify everything, I should get Ex cos inverse x squared minus 2x over square root 1 minus x power 4. And that's it. In example 2, we have to apply chain rule multiple times because for sine inverse, there is a term of secant Ex within its bracket, which means we need to do a chain rule once. And when we are performing the differentiation of secant of Ex, the presence of Ex requires us to perform the chain rule a second time. So let's do a quick recap of the formula that we need. Number 1, if we differentiate sine inverse x, we will end up with 1 over square root 1 minus x squared. And if we differentiate secant x, we will get secant x tangent x. So let's see how we can apply this formula together with chain rule to differentiate this entire expression. So dy over dx equals to 1 over square root 1 minus x squared becomes 1 minus fx squared, which means secant of Ex whole thing squared multiplied by the differentiation of secant of Ex. Now let's try to differentiate this term on the side. To differentiate secant of Ex, it becomes secant of Ex tangent of Ex multiplied by f prime x, which is Ex again. So therefore, the entire term over here just becomes secant of Ex tangent of Ex multiplied by Ex divided by square root 1 minus secant square Ex. And that's it.